All right, so we want to do our example for difference in proportions using Excel. So recall that we had this guest satisfaction survey. We have these observed frequencies. So there are 3 hotels people went to: Golden Palm, Palm Royale, Palm Princess. And they were asked whether they would choose this hotel again, yes or no. Of course, we have our total counts. Okay, so this is our actual data, our observed data. So recall that we needed to calculate our expected counts, or expected frequencies, and it was equal to our row total times the column total divided by the overall total. And we have to square that difference. And no, I'm sorry, I misspoke. The expected count is just the row total times the column total divided by overall. So let's do this cell by cell. So Golden Palm, yes. So we would do equals. Row total is 513 times the column total is 216 divided by the overall total is 700, and we hit enter. Now we're just going to do this over and over for all of these. So equals Palm Royale. So row total 513 times column total 232 divide by overall total 700, enter. Palm Princess equals row total 513 times column total 252 divide by overall 700, enter. Now let's do it for our nose. So Golden Palm. So equals row total is now 187 times our column total 216 divide by our overall 700, enter. Palm Royale equals row total 187 times column total 232 divide by overall 700, enter. Now finally Palm Princess equals row total 187 times column total 252 divide by overall total 700, and enter. Now let's say I want my totals, so I'm going to do equals sum, and I'm just going to select these 2 cells, enter. Now I'm just going to carry this over. Now let me do that the same with the row, so do equals sum. I want to sum up the rows, so I'm just going to select these 3 cells, enter, drag down, and then for the overall, I'm going to do equals sum, and I'm going to sum up all 6 values and enter. So notice that these values here are the same as these, and these are the same as these. So all the totals should be exactly the same between observed and expected. That makes sense because we are just calculating the expected values from the row and column totals. Okay, so we have our observed, we now calculated our expected. Now we want to create our squared differences so that we can just sum all of them up to get our test statistic of chi-squared. So recall that we need to do the observed minus expected, square that difference, divide by expected. We're going to do that for all of these. So let me do equals. I'm going to do 2 left parentheses equals observed minus expected, close parenthesis, caret 2 for squaring it, close parenthesis, divide by expected, and then enter. Again, if you ever need to see these, just come up here to the formula and you can see exactly how I did it. So let's keep doing that. So let's do equals open parenthesis, expected minus, observed minus expected, close parenthesis, square the difference, close parenthesis, divided by expected, enter, we get 4.94. Now I'm just going to keep doing this. Equals open, observed minus expected, close, square that difference, close, divide by expected. Now we're on to the nose, so equals open, observed minus expected, closed, caret 2, close, divide by expected, enter, equals, open, open, observed, minus, expected, close, caret 2, close, divide by, expected, enter, equals, open, open, observed, minus, expected, close, caret 2, close, divide by, expected, enter. Okay, and now we can just sum all of these up. So in this total cell right here, I'm going to say equals sum, and I am going to sum up all of these 6 values, close, enter, and we get 40.23. So our test statistics, so chi-squared stat, that's just going to be 40.23. So I'm just going to say equals this cell. You could also just write 40.23. C minus 1, well, C is 3, right? We have Golden Palm, Palm Royale, Palm Princess. We've got 3 categories, therefore C minus 1. This would be equals 3 minus 1. Enter, we get 2. So chi-squared, so we're actually going to have, so format this. So I want subscript. So this is going to be 2, comma, 0.05. So chi-squared, 2 degrees of freedom, 0.05. We're going to do chi-squared dot inverse dot RT. So just do equals chi-squared dot this dot RT. So x value, that would be our probability, which our alpha here is 0.05, comma, degrees of freedom is 2, close parenthesis, and that is not correct. Let me try that again. I used the wrong function. I am sorry. This should be equals chi-square inverse dot RT. Probability is 0.05, degrees of freedom is 2. And I'll let you look at that for a moment. So chi-square dot inverse dot RT, 0.05 for probability, because we're using alpha 0.05. We're using 2 because we have 2 degrees of freedom. Enter, and you get 5.99, and that is our critical value. So p-value, that's just the probability of chi-squared with 2 degrees of freedom greater than chi-squared stat, which is 40.23. And here, this is where we would use that other function. So this is just chi-squared inverse, or sorry, chi-squared dis dot RT. So x here is 40.23, so I'm going to select that. Or if you want, you could just type it 40.23, comma, degrees of freedom, 2, close parenthesis. I'll let you look at that for a moment. So this is chi-squared dot distribution dot RT. You give it your chi-squared stat, and then you give it degrees of freedom. And then enter, and you get a p-value that is extremely small. And so our conclusion, because chi-squared is stat is bigger than our critical value, we reject, or because our p-value is less than 0.05, we reject, and therefore we reject H naught and accept HA. I'll just highlight that because that is our final answer. Okay, and that's how we do this example in Excel. So it's obviously a little easier to do it like this than by hand on pen and paper.